about aldehydes and ketones and how to name them. So one of the things we're going to look at today is sorts of reactions that these guys undergo. Now there's really only two types you guys need to know about. One you've seen before, which is oxidation, and then we're going to look at the opposite of oxidation, which is reduction. Alright. So we saw before, for oxidation you can go from alcohols to aldehydes or ketones, and reduction means you go from aldehyde to ketones back to alcohols, exactly the opposite. So when we look at aldehydes, we can get to an aldehyde from a primary alcohol by oxidizing it, and we've seen before that that can oxidize further to a carboxylic acid. So if we're starting from an aldehyde, we just have to remember the aldehyde can oxidize to a carboxylic acid no matter what the sort of aldehyde it is. But if you have a ketone, it doesn't really matter what its structure is. Let's say we've got a ketone like this, and we do an oxidation reaction here. What can you guys tell me is going to happen? Well, nothing, no reaction. So the aldehydes can oxidize to acids, as we've seen before, and we've also seen before that ketones cannot. All right. So really, the only thing that we're focusing on as far as oxidation goes is the fact that if you have an aldehyde, you can oxidize it further to a carboxylic acid. And if you've got a ketone, you can't do anything. All right. When we look at reduction, we'll see we go the opposite way from aldehydes back to primary alcohols and ketones back to secondary alcohols. Okay, a couple of tests. And we've seen about these in lab to distinguish between aldehydes and ketones. Tollens test we haven't done, Benedict's test we have done, at least in theory. The only thing I want you to understand from here is that both these tests, whether it's Tollens test or Benedict's test, they give you a different observation to show a positive result. A Tollens test gives you what's called a silver mirror. This is actually a really cool thing. You run the reaction. One of your reagents is silver nitrate, I think it is, and the silver gets oxidized to metallic silver, which deposits on the interior of your test tube and gives you essentially what looks like a mirror. Now that's a oxidation. That's a reduction. I'm sorry. Well, whatever. That reaction goes hand in hand with this reaction here. All right, that's why it's positive for aldehydes. Aldehydes can be oxidized, as we've said before, to carboxylic acids. All right, if you've got an aldehyde of 4 carbons, you can get an acid for 4 carbons. All right, this is the organic product. You have other things happening as well, the silver mirror being one. But in terms of what's happening to the aldehyde, it's getting oxidized. Because this is a ketone, you won't see a silver mirror because this can't get oxidized. All right. So this is a way to distinguish between aldehydes and ketones. Aldehydes give a positive test, ketones don't. Benedict's test. In theory, this works the same way, unless you have Benedict's reagent that doesn't work, which some of us have seen before. This, in theory, gives a red precipitate, a red color that's indicative of the aldehyde being oxidized. The Benedict's test contains a solution of copper sulfate, and during the process that copper gets converted to copper oxide. So this is copper 2+, this is copper 1+. The copper gets reduced, and this is what's red. Alright, this was originally blue. So the copper gets reduced from copper 2+ to copper 1+, and as the copper gets reduced, that's got to go hand in hand with an oxidation, and that oxidation happens with the aldehyde, which again gets oxidized to a carboxylic acid. No color change for ketones because again you can't oxidize a ketone. Alright, so therefore, in theory, you get a brick red color for aldehydes, and for ketones you see no change from the original blue color. Alright. So then, if I ask you, what do I get when I put in Tollens reagent or Benedict's reagent to a ketone? It doesn't matter what these reagents are. You don't need to know the details. You just got to know what we're trying to ask here. We have it for an aldehyde, we have it for a ketone and an aldehyde, and we've seen already that aldehydes react ketones don't. So whether it's Tollens reagent or Benedict's reagent, because both of these reactions require the oxidation of this guy, nothing's going to happen. For this guy though, this is an aldehyde and this can be oxidized. Alright, so it'll be oxidized to a carboxylic acid. And so for this we'll see that color change from blue to red. That's an indication that the reaction has worked, and that's a positive result. For the Tollens reagent, again, it's a positive. It's going to be a positive test because aldehydes can be oxidized to carboxylic acids. Tollens test will give you a silver mirror. What you usually see with this reaction is first like a black precipitate when the reaction starts up, and then when you leave it in hot water, the silver mirror forms. Now that's supposed to be a V. I don't know what happened there. So with aldehydes, for Benedict's reagent and Tollens reagent, you always get a positive test, and for ketones you don't. Alright. Now, that's oxidation. Alright. Reduction is, as I said before, the opposite of oxidation. We've seen how before primary alcohols like this can be oxidized to aldehydes, which, if it's done again, can be oxidized further to carboxylic acids. Secondary alcohols can be oxidized to ketones, and it stops right there. So if this O means oxidation or an oxidizing agent, and it takes you from an alcohol to a ketone, for example, then what would a reducing agent do? Well, it would do exactly the opposite. If an oxidizing agent takes you from a secondary alcohol to a ketone, then a reducing agent will take you back from the ketone to the secondary alcohol. Same thing for primary alcohols, right? So this gives you a secondary alcohol. This is an aldehyde. We've seen that primary alcohols oxidize to aldehydes. They can therefore get reduced in the opposite direction to primary alcohols. You don't need to worry about the specifics of what the reducing agent is, just as you didn't for oxidation. You just got to know what's actually happening. Alright, so we've got a couple of reactions here. Let's see what you guys can do. I want to see if you guys can tell me, first of all, if there's a reaction, and if there is, what the structure of the product is. So Tollens reagent here. Remember, Tollens reagent is a way to tell if you've got an aldehyde or a ketone. Aldehyde gives you a positive result. The ketone does not. That's a ketone, so therefore there'd be no reaction. So we've got Tollens reagent, Benedict's reagent, and Tollens reagent here. If we have a ketone in any of these, nothing's going to happen. That's a ketone, hence no reaction. That's an aldehyde, and that's an aldehyde. So we'll get products in both of these cases. Because we have aldehydes, we're going to get oxidation to the corresponding carboxylic acid, as we've said. We just got to bear in mind that if we had a 3-carbon aldehyde here, we've got a 3-carbon acid here. We have a 5-carbon aldehyde with a methyl coming off the second to last carbon. So our product is going to be the same thing except a carboxylic acid with the methyl coming off that same carbon. All right. Now, these two are reducing agents from aldehydes and ketones. Now, what did we say? We said reduction is the opposite of an oxidation. So if you go from a secondary alcohol to a ketone via oxidation, you'll go from a ketone to a secondary alcohol by a reduction. So all you do is replace the C double bond O with an OH. And actually that's the case for an aldehyde too. We have a reducing agent, the aldehyde gets reduced, write the structure out again, and all you got to do is put the OH where the C double bond O was, and that is your primary alcohol. Alright? So just as primary alcohols can be oxidized to aldehydes, aldehydes can be reduced to primary alcohols. Just as secondary alcohols can be oxidized to ketones, ketones can be reduced to secondary alcohols. Now this last one here, this is just an oxidation reaction. You remember when we did this before, you've got to ask yourself, what sort of alcohol do we have? Well, we got a secondary alcohol there. And if it's a secondary alcohol, we get a ketone as a result. So all we've got to do is draw the structure out again and replace the OH with a C double bond O. And that is the basics of aldehyde and ketone reactions.